Hello, this is Mr. Best. Welcome to section 2.2, polynomial functions of higher degree. This is part 1. We're going to talk about finding zeros of polynomials, which is a huge part of this chapter. We're also going to write polynomial functions given zeros. So the first thing is just to get through some of this terminology and what a polynomial is. And so what you see here in terms of a polynomial function of x with degree n can be written, it looks like a mess, but that's what you're going to see as you get into higher level math is things are going to look a little bit more complicated. You guys know what a polynomial is. It's going to be x raised to a power, and then from there you're just going to go a power down in descending order all the way down to the constant a sub 0. The a sub n minus 1, those just represent your coefficients in front of the variable of x. So that's all that what looks to be a mess of things represents as a polynomial function of x, where degree represents n. So the degree of the polynomial function determines a couple of things. So the degree is the highest exponent of the polynomial. So that'll give you the general shape of the graph, which we'll talk about in a second. It'll give you the maximum number of relative max and mins, and I'll show you that as well. It'll give you the maximum number of x-intercepts that you can have, and then it'll give you the maximum number of roots, which is what we're going to be doing a lot of in terms of solving. The graph of polynomial functions are continuous with smooth, rounded curves. Sorry, that kind of went together there. Smooth, rounded curves. So there's no breaks in the graphs of polynomial functions. So what you can see I have here is x squared, x cubed, and x to the fourth, and x to the fifth. And so what I'm going to do is just give you the general idea of what each of these could possibly look like. So f of x equals x, you guys know that is a line. So we can have positive slope, negative slope, whatever. X squared, you guys know is a quadratic. We know that is a parabola, open, up, or down. X cubed, you might not be as familiar with, but here's the general shape of a cubic, where it'll begin and end in opposite directions. X to the fourth could potentially look like a quadratic, or it could look something like this where there's multiple kind of curves going on there. But you can see as it starts and ends in the same direction. And x to the fifth will look similar to a cubic, but once again you might see a couple extra things going on in there. But once again, when you look at your even degrees, x, x cubed, and x to the fifth, look how they all start and end in opposite directions. So they all start and end in opposite directions. Whereas if you look at the x squareds and the x to the fourth, the even degrees, they start and end in the same direction. So things that we'll talk about as we move forward with polynomials. All right, zeros of a function. All numbers x such that f of x is equal to 0. So when the output is 0, what is that value of x? Those are the zeros of the function. What is x when y is 0? Zeros of a polynomial function, two things that we can look at. For all polynomial functions of degree n, once again, that's that highest exponent of the polynomial, the function has at most n zeros. So with zeros of a function, you can have at most whatever the degree might be. So if it's an x cubed, you could have potentially 3 zeros. Also, we'll talk about roots, solutions, and x-intercepts in terms of those similarities between those four different words: zeros, roots, solutions, and x-intercepts. The graph has at most n minus 1 relative max and min. So we've talked about relative max and mins before, and we've calculated them on the graphing calculator. But if you have something like this, which would potentially be an x to the fourth, you could have 4 zeros, but you would only have 3 relative max and mins. So 1, 2, 3. So that's at most how many you could have. It doesn't mean you have that many. At most you could have one less than the number of degree that you have. Real zeros of a polynomial function. If f is a polynomial function and a represents a real zero or a real number, the following statements are equivalent. X equals a is a zero of the function. So if x equals a is a zero of the function, then we also know that x equals a is a solution for the polynomial function when f of x is equal to 0. We also know that x minus a is a factor of the polynomial, and we'll talk about that on some of our examples. And then we also know that a comma 0 is an x-intercept of the graph of f. This is for only our real zeros. When we get into the complex number system, this doesn't necessarily apply because it doesn't cross the x-axis with a complex number. So these four things represent, are basically equivalent to each other when you're talking about polynomials. Now, one of the big things that we're going to be doing with polynomials is we're going to be solving for these polynomials different ways. The first way that I really want to focus on is factoring, and I'm going to show you three different ways that we can factor higher degree polynomials than just quadratics. So we're going to find all the real zeros of each of these functions. So x to the fourth minus 8x squared minus 9. That looks like a quadratic in terms of the trinomial, but it's an x to the fourth. But you kind of treat it the same way when it's x to the fourth x squared constant. So if I asked you, what are your factors when you have a negative 9 that needs to add to negative 8, what numbers multiply to negative 9 to add to negative 8, you're going to tell me that normally you would factor this as x minus 9 and x plus 1, and that would give you x squared minus 8x minus 9. But we need x to the fourth. So what we can do is take our first terms and make them x squared. That would create an x to the fourth. And then what you have, and I'll just show you, when you multiply this out, you'll have x to the fourth plus x to the second minus 9x squared minus 9, which gives you your original x to the fourth minus 8x squared minus 9. Now we are setting this equal to 0, because remember we're talking about when f of x is equal to 0 for real zeros. And then now we can factor this again. The x squared minus 9 is a difference of squares, so we'll factor that again into x minus 3 and x plus 3. The x squared plus 1 is not a difference of squares. It cannot be factored again. Okay? And then so we have three factors. X minus 3 could equal 0, x plus 3 could equal 0, and the quadratic x plus 1 could equal 0. So when we solve all three of these, we get x equals 3 as a solution, x equals negative 3 as a solution, and if we try to solve this one, we get x squared equals negative 1, and when you go to take the square root, you'll get plus or minus the imaginary value of I. Now, since it only asks for the real zeros, we wouldn't list those as our solutions, but they are zeros, they're just not real zeros. So our only real zeros are negative 3 and 3. Okay? Now, in terms of the degree, it's a 4. So we have 4 total zeros, negative 3, 3, and then plus or minus I. And we also have a general idea of what the shape of this graph looks like. But those are our real solutions, or real zeros. On the next one, you can see we have 4 terms. So this is different than the first one. With 4 terms, we look for grouping. So we want to group the first 2 and the last 2 together, factor out the GCF. So on 3x cubed plus 2x squared, you factor out an x squared, and that'll leave you with 3x plus 2. And then on the negative 27x minus 18, you can factor out a negative 9. So negative 27 divided by negative 9 is 3, so that's 3x. And then negative 18 divided by negative 9 is plus 2. These two binomials, when you're doing grouping, should be the same. And then your x squared minus 9 represents your other factor. So we set this equal to 0 again because we're trying to find the zeros, and we have our new factors, x squared minus 9, that's what's in green, and then 3x plus 2 is our other factor. Once again, x squared minus 9 is a difference of squares, so you have x minus 3 and x plus 3, and then 3x plus 2 is equal to 0. The degree is 3, so we should be getting 3 solutions here, and you can see the 3 factors that we have. So we set these factors equal to 0. This is the zero product property, and then you solve each of these. So once again, we get 3, negative 3, subtract 2, divide by 3, and that's negative 2/3. So our 3 solutions would be x equals, use the curly bracket there, or brace. You have negative 3, comma, and we put this in numerical order, negative 2/3 and 3. And so those are your 3 solutions to the cubic. And remember, solutions, real zeros, that's what we're looking for here. And I didn't have any imaginary complex numbers here, so just those 3. All right, on the last example here, you only have 2 terms. Another way that we can solve by factoring is when there's common factors involved in all the terms. So you can do GCF. So we can factor out on this one a negative 2x to the 3rd power. That would leave us with just an x squared. And then if you factor negative 2 to the x cubed out of positive 2x to the cube, then that would be a negative 1. Think about distributing that back through. Would you get the same thing? And so it looks like we have a difference of squares here, so we can factor the x squared minus 1 into x minus 1 and x plus 1. And you're looking in terms of how many zeros we should have, which is 5, and you might only see potentially 3 here, but I'm going to show you that x cubed is actually negative 2 times x times x times x. So there's actually 3 factors of x there. And so if I set all these factors, the negative 2 doesn't matter, but if I set all these factors equal to 0, you would actually have 3 factors of x, so you have 3 zeros. It just so happens that they all represent the same thing, and so they are repeated zeros. Now when you go to write your solution, you don't write 0 3 times. You just write it once. You say negative 1, 0, and 1. But there are a total of 5 zeros there, or 5 factors as well. And then the last thing is find the polynomial function with the following zeros. So I'm going to give you the solutions, or the zeros, and now I want you to work backwards to create the function itself. So if you think about this, if this was our solution, x equals negative 1/2, x equals 3, x equals 3, and x equals 0, now I got to figure out what the factors are. So for the fraction, we don't want to deal with the fraction, so we're going to multiply both sides by 2, so that'd be 2x equals negative 1. Then add the 1 to the other side, so 2x plus 1 would be our factor. If you subtract 3, that would be x minus 3, and I have 2 of those. And then the x equals 0 is just a factor of x. So once you find out what each of these factors are, then you're going to multiply all of them together. So 2x plus 1, x minus 3, and x all get multiplied together to create that polynomial function. So f of x is equal to 2x plus 1 times x minus 3 times x minus 3 times x. So how you want to multiply those 4 things together is up to you, but you can only multiply 2 things together at a time. So I'll multiply the x minus 3 times the x minus 3. That would give me x squared minus 6x plus 9. And then I'll go ahead and multiply the binomial and the trinomial. So that would be 2x cubed minus 12x squared plus 18x plus x squared minus 6x plus 9. I'll have to combine my like terms, and then that will get multiplied by x. So it looks like we will have 2x cubed minus 11x squared plus 12x plus 9, and then each of those gets multiplied by x. So my final answer would be f of x equals 2x to the 4th minus 11x cubed plus 12x squared plus 9x. So if we solve that polynomial, those would be the solutions that we got. X equals negative 1/2, x equals 3 would happen twice, and then x equals 0. Alright, in the last example here, you can once again start the same way, saying that x equals negative 5 is the root, and x equals 2 plus or minus the square root of 11 is the root. Once again, set it equal to 0 so that you can get your factor. Now on this next one, you're going to go ahead and subtract the 2 and get the radical by itself. And then at this point, if you square both sides, that will eliminate the radical and give you just 11. It doesn't matter if it's positive or negative. The radical goes away and it's positive 11. And now if you subtract 11 to the other side, you get x squared minus 4x minus 7. And then go ahead and multiply those 2 factors together. And so you can now see multiplying the binomial times the trinomial. I expanded it all out, used the distributive property with the x on all 3 and then the 5 on all 3. Combine my like terms, got f of x equals x cubed plus x squared minus 27x minus 35. So that's how you take the roots or the zeros of a polynomial function and work backwards to figure out what function gives you those roots.